In the last video, we just looked at what the different attributes of these graphs are and a little bit talked about how to find them. This time we're going to pay a lot more attention to an actual graph and list the different attributes as they pertain to one specific graph. So let's go back and use this graph that we had created earlier and talk about all those different attributes. So we had them listed down below: increasing, decreasing, positive, negative, domain, range, max or min value, and the value of the max or min. So let's kind of start with domain and range. Domain and range are somewhat straightforward for parabolas. The domain of a function is found by scanning the graph from left to right, and then we list all the values that are the x values that are defined on the graph. Now, one thing to keep in mind is that the left end of this graph is negative infinity and the right end of this graph is positive infinity. So I want to ask myself, would this graph be defined all the way out here at negative infinity? And the answer to that is yes, because this graph continues to creep outward. So from negative infinity, as I go left to right, there's no holes or gaps or anything crazy. So it keeps being defined, being defined, being defined. And then what happens when I get out here at positive infinity? Is the graph still defined? Well, yes it is, because this graph continues to grow outward, 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 outward until so forever, really. So it keeps going out, 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 out. So the domain for this graph, and actually for every single parabola, is going to be negative infinity to infinity. Now the range is a different story. The range, we're going to start reading at negative infinity. So the bottom arrow is negative infinity for the y values, and the top arrow is positive infinity. So as I scan my graph from bottom to top, is there any graph down at negative infinity? No, there's not. The graph does not start until this point right here, which is the vertex. And we already knew the vertex from before was at negative 2, negative 5. So let's label it negative 2, negative 5. So we want to know what y value is the very first y value we're going to encounter as we're scanning this graph. And it's this one right here, which is negative 5. So the parabola will be defined for the range, negative 5, and then it keeps going forever, forever, forever. So it will go from negative 5 to infinity. Infinity always gets a parenthesis, and in this case, negative 5 will get a bracket because we have a solid dot on that y value. Now let's talk about this maximum or minimum value and the value of the max or min. Now that gets to be a little bit confusing sometimes for people, but really what you have to consider for the maximum or minimum is think to yourself, like, could I give a value that would be the lowest value this function gets to, or could I give a value that would be the highest value? This function continues going forever, forever, forever. So it really goes up to infinity, but I can't name that as a maximum value because you can never get there. So this graph actually has a minimum right down here at the vertex. So this graph has a minimum, and the minimum value is the y value. So that minimum value is the y value of the vertex, negative 5. So it has a minimum. So then the value of the minimum will be negative 5. Let's look at increasing and decreasing. Remember that increasing and decreasing has to do with whether the graph is going uphill or downhill, and we read that left to right just like we do the domain. So as I go left to right, when I start out here at negative infinity and I move along the graph left to right, would I be going uphill or downhill? As I go left to right, this graph is going downhill, so it will be decreasing from negative infinity up until it quits decreasing and turns around right here. So from negative infinity to this point right here, which is at negative 2, negative infinity to negative 2, it's decreasing. And we're going to use an open parenthesis for the x value on decreasing because it's not still decreasing here, it's turning around. So So then at negative 2, it turns around and starts increasing. So it's increasing from negative 2 all the way over to infinity. So it's increasing from negative 2 to infinity. The last attribute we're going to talk about is positive and negative. Now, positive and negative refers to where our graph is above and below the x-axis. So let's look at above the x-axis first. So if we cover up the part of the graph that's below, then now we're only looking at the part of the graph that's positive. And we're going to list these as x values in interval notation as we go left to right. So it is above the x-axis all the way out at negative infinity on the x value, and it's still above the x-axis until we get to this spot right here. Now you may remember this spot was our x-intercept right here. So this is the x-intercept, negative 2 minus the square root of 5, comma 0. And we're looking at x values, so our function is positive for all the x values between negative infinity and negative 2 minus the square root of 5. So it's positive in this area, and then it's positive again in this area. So positive in this area. This point right here is the x-intercept, negative 2 plus the square root of 5, comma 0. And if we look at below the x-axis, it's below the x-axis here. So it's negative in all of those regions. So as we go from left to right, we can start listing our x values at negative infinity. So at negative infinity, it's positive. So the graph is above the axis, so it's positive. So negative infinity on our positive section, up to the last spot it's positive, is just before negative 2 minus the square root of 5, and we give that an open parenthesis. And then at negative 2 minus square root of 5, notice that it starts being negative. So we'll go into the negative section, and it will be negative from negative 2 minus square root of 5 up until this spot right here, which is negative 2 plus the square root of 5. And then it's positive again. Positive, 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 all the way out to infinity. So we'll put a u here, and then we'll start up again at negative 2 plus the square root of 5, all the way to infinity. Let me see if I can zoom this out a little bit so you can see the whole page at once, so we can kind of summarize. That's a little bit better anyway. Now you can see all my extra junk here. Okay. Increasing and decreasing. So as I go left to right, the graph is decreasing from negative infinity up to this spot right here, then it starts increasing again. So it's decreasing negative infinity to this x value, x equals negative 2. So negative infinity, negative 2. Then at negative 2, it starts increasing, and it goes uphill all the way to infinity. Positive and negative. Remember that positive means above the axis, negative means below. So anywhere your graph is above the axis, we can kind of write plus, 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 and then below minus, 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 minus. And then you look on this number line from negative infinity to negative 2 minus the square root of 5. It's positive, so that's this part. And then again it's positive from negative 2 plus the square root of 5 all the way to infinity. It's negative between negative 2 minus the square root of 5 and negative 2 plus the square root of 5. This graph has a bottom value, a minimum value. The minimum value is the y value of the vertex at negative 5.